Hey, everybody. We are in lesson 7-2 on parallelograms. This is the Tennessee Reveal Geometry. All right, well, listen, there are 5 things you need to know about a parallelogram. So I'm hoping that this is going to tell us. Okay, perfect, right here. So on page 413 of your workbook, it tells you right in the middle of the page, these are the basic things you need to know about a parallelogram. All right, so first off, a parallelogram is a quad. That means it has 4 sides, 1, 2, 3, 4, and both pairs of opposite sides are parallel. So your top and your bottom will be parallel. That's your opposite sides, and your left and your right will be parallel. All right, so it's a parallelogram. Now listen, parallelogram kind of has its own little family. A rectangle is a parallelogram. A rhombus is a parallelogram. A square is a parallelogram. But the trapezoid is not, because it has to have 2 sets of parallel sides, and the trapezoid only has 1 set. All right, so you need to add on to that these down here. All right, if a quad's a parallelogram, then its opposite sides are congruent. So the ones that are parallel will be equal to each other. All right, if it's a parallelogram, then opposite angles are congruent. So this obtuse B and obtuse D are congruent, and the acute A and the acute C are congruent to each other. All right, next one. If it's a parallelogram, then the consecutive angles are supplementary. So what I mean by that, visual people, small angle A, big angle D, acute and obtuse, they're going to add up to be 180. So D and C will add up to be 180. C and B will add up to be 180, and B and A will add up to be 180. All right. And if a parallelogram has 1 right angle, then it has 4 right angles. And that's really when you get into your a rectangle and your square. All right, so let's keep on going. Get to our first example. Okay, so it looks like I'm at the bottom of page 413 of your workbook, and they're asking opposites. Okay, yeah. So they're asking for CD. Well, its opposite side is AB, which is 4. So it looks like it is going to be 4 feet. Easy breezy. All right, let's see what's going on. Okay, so I'm turning the page for our check. Okay, so again, they're asking about opposites. So I'm on the top of page 414, and they want angle D. Well, angle D is obtuse. It is opposite to F, which is obtuse, 106 degrees. FG is a side because it has 2 letters. It is opposite to ED, and that's going to be automatically 8. So there's your answer for your check. All right, example number 2. Okay, it's a proof. So listen, we don't do this in Tennessee anymore. They took it out of the curriculum. Thank you, the Lord. So I'm going to skip this. It looks like the check is also a proof. All right, so I'm so thankful they took that out. I don't have to worry about it. All right, so I am on example 3. This is page 415 in your workbook if you're following along. And it's talking about the diagonals. I was wondering when they were going to say this. You guys, the diagonals of a parallelogram, they bisect each other. If you've forgotten what bisect means, it means they cut each other in half. So AC and BD bisect each other. That means AE is congruent to CE, and DE is congruent to BE. So bisect means to cut into 2 equal parts. All right, let's see what they're going to have us do here. All right, got to find the value of X and Z of this parallelogram. And it says ADC, which is this big angle D, not the little bitty sections, but the entire thing is 4X. DAB is 2X minus 6. Okay, well, the rule says that these 2 angles are supplementary. And what that means is they add up to be 180. So it's going to be 180 equals these 2 added together. So I'm going to put 4x plus the 2x minus 6. Oh, come on. Why do we want me to do that? It doesn't make any sense. Fine. 2x minus 6. All right, there we go. Get off of there. Okay, so I need to have some like terms. So to help out my visual people, 180 equals 4x plus 2x minus 6. Okay. Well, 4x plus 2x are like terms, and 4 plus 2 is 6. So now I've got 6x minus 6. The opposite of subtracting 6 is to add 6 to the other side. So 180 plus 6 is 186, and that equals 6x. And the opposite of multiplying by 6 is to divide by 6. And 186 divided by 6 is 31. So x is 31, everybody. 31. All right, now it looks like they're going to have me doing some plugging in. They want the value of z. No, I'm not plugging in. I'm doing a whole different equation. Okay, so, well, these are in the diagonal, and the rule says these diagonals bisect each other. Okay, first off, no degree mark. No degree mark. These are not angles. And listen, if you're a teacher brand new to geometry, I will have multiple students every year try to add those to be 180. And you guys, they're not angles. So angles will add up to be, 90, 180, 360, whatever the problem is having you do. But these are not angles. These are sides. And in fact, this is the diagonal more specifically. So set them equal to each other. So 3z minus 4 equals z plus 5. All right, picky. Z plus 5. There we go. All right. Okay, let me find a place where I can set this up. All right, so we set them equal to each other. So we've got 3z minus 4 equals z plus 5. Okay, well, I am going to subtract the smallest z to the other side because I like a shortcut. So minus z right here will cancel this one out. Minus z over here is going to leave me 2z. Just 3, take away 1 is 2. It leaves the 5 on the other side. The opposite of subtracting 4 is to add 4. So add 4 here to cancel it out. Add 4 on the other side. So 2z equals 9. Ooh, I'm going to get a decimal. Divide by 2, because the opposite of multiplying by 2 is divide by 2. It looks like we're going to get 4.5 or 4.5 or however much your teacher wants you to do it. All right, so 4.5 is our z. Oh, okay, done with example number 3. All right, moving on to example number 4. Let's see, we got scrapbooking. Thomas is making envelopes to sell with handmade cards. He uses a different style of paper to create the flap of the envelope, and he edges the envelopes with, I have no idea how to say that. Is it washi tape? Okay, I'm going with that, washi tape. The envelopes are parallelograms, and the edges of the flaps lie along the diagonals of the parallelograms. Find the area of the flap and the perimeter of the envelope. All right, so we're finding the area of this purple thing, and we are finding the perimeter of the envelope, the entire thing. All right, part A. All right, here is our formula for the area. The formula for a triangle, because it's obvious this is a triangle, is 1/2 base times height. Okay, let's see. What did they do here? They found the midpoint? Why would you find the midpoint and not just count it? Because each one is one unit. I would just count it. So over 0 up 2, they're saying is the midpoint. Okay, so 1, 2, 3, 4, 5 would be the height. Okay. Oh, yeah. So 7 minus 2 is 5. Wow, they made that more difficult when it had to be. You guys, come on. Look at this triangle. This AB, whatever this is, 0, 2 point. It's a nice problem. This is your height. Count the boxes. This is your base. Count the boxes. So it's going to be 1/2 times however many your base is times 5. So our base is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. All right, so my base is 14. You can count the, oh, right here it says you can count. I didn't just count the other one then. All right, so let's see, 1/2, 5 times 14. All right, so, all right, grab your calculator. 5 times 14 is 70, and take half of that is 35. So our area for, let me go back, for the area of this flat, this purple triangle is 35. And that should be square centimeters. Okay, now we got to find the perimeter. Okay, so what do they want me to do here? The length of the envelope is the same as the base. Well, that was 14. There'll be 2 of those, by the way. All right, yeah, they do it. Example, sorry, in step 2, there's your 14. All right, so they want us to find the width. So they're just counting out 7 up, 3 down, makes a total of 10. So they're going to have 2 of those, and that's why it's 2 times 10. Oh, they did this for us, which is nice. That's 48. Okay, so yay, they did that for us. Very nice. All right. If you haven't turned the page yet, we're on page 416 at the bottom on the check. This looks like our last one because I'm looking at practice problems on the next page of your workbook. All right, quilting. All right. Jamina is making a quilt. Each block is a parallelogram made of a single piece of patterned fabric and is trimmed with a gray border. Find the area of the fabric used to make the block. Find the length of the fabric used to make the border of the block. That's perimeter. And find the nearest tenth if necessary. All right. Well, I'm going to open up my GeoGebra. And I'm going to draw this sucker out. All right, so let's see, what are my dimensions? I need 3 all the way in every direction. Okay, no problem. I just want to make sure I have it big enough. Go to my polygon, over 0, up 3, 3, 0, 0, negative 3, negative 3, 0, and then straight back. All right. So I need to find the area. So I need to find the length of the side here. So it's going to be base times height, or length times width, or side times side. All right. So to me, it looks like a square. So let's see. I'm going to find distance. And if you haven't realized, it does give it to you. If you don't realize, you can go under the 1, 2, 3, 4, 5, 6, 7, 8th icon, and you see distance. Click on one of the sides, and you can see it's 4.24. So if you don't realize the distance is over there, this is a square because every single side is 4.24. Now, to find the area of a square, it's just side times side, length times width, base times height, 4.24 times 4.24. All right, so grab your calculator. 4.24 times 4.24. Don't forget, they want us to round to the nearest tenth, and that will be 17. Ooh. Back up the train. I got a 0.97. Well, that 7 is going to make that 9 round up. So it's no longer 17. It is going to be 18. All right, so our area is 18 squared centimeters. All right, perimeter. That is when you add up all 4 sides. So your choices are add all 4 of these, or realize that they're all the same. 4 times 4.24 will get you the same answer. And that's going to be 16.96. 16.96, and they want us to round to the nearest tenth. So that 6 is going to make that 9 go up, which makes the 16 go to 17. I got 17 centimeters. All right, you guys, if you don't have GeoGebra or anything like that, you're welcome to do Pythagorean theorem. So you visual people, 1, 2, 3. 1, 2, 3. It would be 3 squared plus 3 squared equals c squared. And if you're sitting there going, saying, now what? Do that one more time. Up 3 over 3 is 3 squared plus 3 squared equals c squared. That's called the Pythagorean theorem. That will get you the length of every single side, which is going to be 4.24. All right, guys, good luck. If you have any questions, let me know. Ask your teacher. That's the best way to learn. Ask questions. All right, you guys have a great day. Bye.